Hello everyone. The name of our project is Ophthalmic Disease Recognition Using Machine Learning, which is presented by myself, Advait Patil, SAP ID 4, Jayasha SAP ID 21, and Nikhil Soni SAP ID 35. The main purpose of this project is to automate disease detection, as ophthalmic diseases are very common in today's world and the affected number of people are in billions. To do this, we use three different convolutional neural networks, which are ResNet 50, DenseNet 201, and Inception V3. Right now, we only try to detect three distinct diseases, which are diabetic retinopathy, age-related macular degeneration, and glaucoma. The datasets used for the same are DIRECT DB0, ADAM, and Refuge. Now, I would like to invite Jay to continue with the next.
Okay, thank you, Advait. Before we look into the model, let's first look at how we process our data sets in order to enhance the abnormalities present in the image. So for that, we first resize our data set, the images. Resizing of the image is basically done to modify the size of the image without cropping or losing any information from it. In our project, we have done resizing in order to reduce the data set and data set size and to get all the images of the same size. The next we do is grayscaling. Grayscale images are images where the value of each pixel represents the intensity level of the light. This is basically of three colors, namely black, white, and gray, where gray has multiple levels. So next in line is circular crop. The main area of concentration in the fundus image is the pixels that are in the circle with the center as origin. The side regions of the fundus image do not contribute in determining the disease of a patient. Due to this, circular crop function is applied to get rid of any unnecessary region and concentrate only on the pixels that will help in determining and classifying the images in a better way. Next in line is the image data generator. So image data generator provides a way to work batch wise instead of working on the whole data set. The image data generator provides two methods to accept data. They are flow from directory and flow from data frame. In case we want to augment the data or increase the data set, the image data generator provides different augmentation techniques such as horizontal or vertical flip, zoom range, rotation range, brightness range, etc. So as you can see on the screen, the image you see is the final image after grayscale, Gaussian blur, and circular crop. So we have just shown the different augmentations we've done here, but we haven't used augmentation techniques in our project as the dataset we got was enough for our project. Next, to explain the models, I'd like to invite Nikhil. Thank you.
So before moving on to the model, we'll have to split the data into train, test, and validation. So for that, we are using the split folders library provided in Python. So as you can see here, we are making a ratio of 60%, 20%, and 20% for train, test, and validation respectively. Okay, so after the data is split into three folders, that is the train, test, and validation, we train the model. The first model that we'll be training is the ResNet 50 model as described by Advait. So here we are using image data generators as explained by Jay, because image data generators allow us to process images in batches instead of working with all the data set at once. So here we have kept the batch size at 16. So if we do not want to specify a particular batch size, the default batch size is 32. So as you can see, we have created a universal data gen, and using this data gen, we'll be creating the train generator and valid generator for training the model. So after that, this is the main thing where we are creating the model. So as you can see, the base model is ResNet 50, and the weights used are ImageNet. So ImageNet is a big, we can say it is a big weight providing system. So it provides weight to classify over 1,000 classes, which means that we can classify 1,000 types of classes while using this ImageNet weights. So as we can see, the include top argument has been given as false. That is, we are not including the fully connected layer. So this becomes our base model. Now we'll be adding some additional layers to this model so that it classifies according to our problem statement. So as you can see, we are using the global average pooling 2D layer because this layer averages the feature map instead of connect the fully connected layers on the top of the feature map. Next, we are using a dense layer. So dense layer is the most common layer used to build a model. Here we are using the activation function as ReLU. So ReLU has only two outputs, either 1 or 0, depending on the function, and it helps us to prevent the exponential growth in the computational. Okay. So next we are adding another layer for prediction. So this is a layer where we are providing the data set. As you can see, the train data generators.num classes, and we are using softmax function because this function is used for multiple classification problems. So we can run this to for just 5 epochs just to show that the model is running correctly. Okay, so as you can see, the validation accuracy is quite high. That is, it is approximately reaching to 1 in some of the epochs. So to computationally, it is coming out to be 90 around 94%. So after this, we can plot this frequency of the validation. This is just for visualization. Next, we'll save the model and then we'll use this model to make predictions on the data. So this is the confusion matrix which has been plotted for the testing purpose. So as you can see, the numbers that are shown on the diagonal are the correct predictions, and all the numbers that are other than in diagonal places that are wrong predictions. So for example, on the x-axis we have the predicted values, and on y-axis we have actual values. So we can see on the healthy column and DR column, there are three images which has been predicted incorrectly. We have printed out the values of the predicted class and the actual classes. So these are the predicted classes and these are the actual classes of the images. So we can see that for this particular case, the predicted class is healthy, but actually it is a DR. Therefore, this is an incorrect prediction. So along with this, there are some more. Similarly, test, we'll train models for DenseNet 201 and Inception v3, and we'll check their accuracies as well. So as you can see, here we are getting an accuracy of about 94 in one of the epochs and around 70 and 77 in other epochs. So after complete training, we can see the confusion matrix for DenseNet, and we can see that this is not better than the ResNet one. And again, in Inception v3, the same thing is done for Inception v3. We can see that here the accuracy is even lesser as compared to other two models. So after comparing the confusion matrix and the accuracies, we find that the ResNet 50 is the best amongst the three. So we have been using that for the testing purpose. Now we'll see the random testing of some of the images. So we have created a folder called random test. So let me just clear out this folder first. Okay, so the random test contains few random images. So these images can be in any format, and we'll see how this testing is done. So this is where we load all the libraries. Now we'll load the random folder. So these are the same function as which we have been using for data pre-processing, because we'll need to feed the model image in a way that it is used to. Okay, so now we are converting each and every image in the form in which we'll feed it to the model so that it can predict correctly. So after this conversion, we can see that there is a directory called test images which has been created, and we can see the images have been pre-processed. Okay, so now we'll load the model that we saved earlier. Okay, so now for the final part, we'll make predictions. So as you can see, this cell is currently being done. Here we are also assigning the labels, that is, the image can be from one of the four classes: ARMD, DR, glaucoma, or healthy. So these prediction labels have been assigned to each of the images. So as you can see, for each of the images, the prediction is shown. For better visual representation, let's run. Okay, so here we see that all the images that we put in the random folder have been predicted. and we can see that this particular image is clearly glaucoma image. So we can say the predictions have been done fine. So I would like Advait to continue from here.
So as we can see from our project, the results which we obtain on a controlled and clean data are quite impressive. Although in the real world application, with many more diseases and many more parameters to consider for each given image, just one neural network is often not enough, as an accuracy of even 99% could mean that the patient gets wrong information and the treatment. Thus, this is a lot of scope for improvement in the future, as Google's DeepMind has already shown. So, this was our project. Thank you.